Today we will be discussing relational database. So this is the first part of relational database modeling. At the end of this discussion, you are expected to define the different terms involved in a relational database, understand the use of supertype subtype relationships, understand use of specialization and generalization techniques. Then you should be able to specify completeness and disjointness constraints, develop supertype subtype hierarchies for realistic business situations. Then you should be able to know how to develop entity clusters, explain universal data package, and describes special features of data modeling project using project data model or package data model. So first we go to supertype subtypes. When you say supertype subtypes, it is an extension or an expanded ER diagram. So it is what we call the enhanced ER diagram. When you say EER, it extends the original ER model with new modeling constructs. Now, these new modeling constructs are composed of supertype and subtype. When we say supertype, it is a generic entity type that has a relationship with one or more subtypes. On the other hand, when we say subtype, it is a subgrouping of the entities in an entity type that has attributes distinct from those in other subgroupings. Basically, when you say supertype subtypes, it is also known to be the parent-child relationship of entities. Supertype is considered to be the parent, while subtype is considered to be the child. Now, when it comes to attribute, there is what called attribute inheritance. All subtype entities inherit values of all attributes of the supertypes. And an instance of a subtype is also an instance of a supertype. This means that all attributes from the supertype is being inherited by the subtype. And all the instance of a subtype is also an instance of a supertype. So let us now hear the common notation of a supertype subtype. So you have here the supertype and you have here subtypes. A subtype can compose of one or more entities. Now remember, when you say attribute inheritance, all attributes from the supertype are being inherited by the subtypes. However, the attributes from the subtypes are not inherited by the supertype. And in this case, a supertype can also have a relationship with other entity, and a subtype can also have a relationship with other entity. So let's have here an example of a supertype subtype with three subtypes. So we have here the supertype employee, and we have three classification of employees. You have hourly employee, salaried employee, and consultant. So all employee subtypes will have employee number, name, address, and date hired. So all the attributes from the employee entity, which is the supertype, is being inherited by each of the subtypes. That is the hourly employee, salaried employee, and consultant. Now, each employee subtype will also have its own attribute. So the attribute of each subtype is exclusive only for that particular subtype. It is not being inherited by the supertype. So let's go to relationships and subtypes. Relationship at the supertype level indicate that all subtypes will participate in the relationship. And the instances of a subtype may participate in a relationship unique to that subtype. In this situation, the relationship is shown at the subtype level. So to demonstrate the relationship of supertype subtype, let's have this example. So when you say the supertype, which is the patient entity, it has a relationship with an entity responsible physician. So this relationship between the entity responsible physician and patient will also be inherited by the subtypes. Will also be part, or these subtypes are also part of the relationship between the supertype patient and responsible physician. But the relationship between a subtype and another entity is exclusive for that subtype alone. It will not be affecting the supertype and the subtype. So this particular relationship between a subtype and another entity is exclusive for that particular subtype. So let us try to discuss further this supertype subtype relationship. So we have here the subtype patient. We have here the subtype patient. So the subtype patient, as a patient, can either be outpatient or resident patient. So when you say resident patient, that is admitted patient. Now, in every patient, whether it's outpatient or resident patient, there is a physician assigned to him or her. That is why the relationship between the responsible physician and patient is cascaded through the two subtypes, outpatient and resident patient. Right? So each patient will have his own physician, whether he is an outpatient or a resident patient. Now, if in case that a patient is a resident patient, it is only the resident patient that will be assigned with bed. Example, he occupies one hospital bed. So that is why the relationship between resident patient and bed is exclusive for these two entities. And the relationship between these two entities is not carried over or cascaded to the outpatient subtype, neither to the patient subtype. Now let's go to generalization and specialization. So when you say generalization, it is more of a bottom-up approach, and specialization, it's a top-down approach. So when you say generalization, you are first given the different subtypes, and then you draw or you derive the supertype for those subtypes. So meaning you already have the subtypes. Given those subtypes, you can generate the supertype. While on the other hand, you have the specialization. When you say specialization, it has the top-down approach. So in specialization, you are given the parent or the supertype. Based from that supertype, you generate all the different subtypes associated with the supertype. So that's the top-down approach for specialization. So let's have an example for generalization. Given that you have these three subtypes, car, truck, and motorcycle, then you have to generate the supertype. So to generate the supertype, you have to look for the common attributes of all the different subtypes. So for the common attributes of vehicle ID, price, engine displacement, and vehicle name. So as you can see, these attributes are present in the three subtypes. So from there, you will be able now to derive the supertype and have the supertype subtype relationship model. So in this case, we will have this. So you have your vehicle as your parent or your supertype. Then you have car and truck as your subtype. The reason why there is no motorcycle here, notice that we have a motorcycle as one of the subtypes. The reason why we don't include motorcycle as part of the subtype is that motorcycle does not have its own unique attribute. What it has are the attributes present in the supertype, which are vehicle ID, price, engine displacement, and vehicle name. So if you can recall the definition earlier, a subtype can only be created if that particular subtype has its own unique attribute, If there is no unique attribute, or if there is no attribute associated for that particular subtype is part of the, or will become part of the super type. That is the reason why we don't have motorcycle as one of the subtypes. Now let's have an illustration for specialization. We have here the generic or the general entity part. Now we notice that we have two identifying attributes here. You have the routing number and the supplier. The supplier is a composite attribute. Now, looking at the routing number, this routing number only applies to manufactured parts. When we say manufactured parts, the company is the one manufacturing or producing that particular part. When you say purchased part, the company purchased that particular part from another vendor or from another supplier. So from this, we can now derive we can create the two subtypes for the part supertype. So we now have the manufactured and the purchased part. For the manufactured part, we have the routing number as its unique attribute. Now for the purchased part, notice that the purchased part here, we have the composite attribute supplier, which is the supplier ID and unit price. So that purchase part has a relationship to two other entities, which is the supplier and an associative entity supplies. So a purchase part is being supplied by one supplier with a particular price. So note that a multi-valued composite attribute was replaced by an associative entity with a relationship with another entity. Now let's go to constraints in supertype subtype relationships. So the first type of constraint in a supertype subtype relationship is what we call the completeness constraint. When we say completeness constraint, whether an instance of a supertype must also be a member of at least one subtype. So take note, must also be a member of at least one type. So for the completeness constraint, you have total and specialization rule. To model the total specialization rule, you have double line. Partial specialization rule, single line. So let's have an illustration of completeness constraint with total specialization rule. So by definition, the instance of a supertype must also be a member of at least one subtype. So in this, we have a total specialization because a patient has to be either. Once a patient should be classified as either outpatient or resident patient. That is why it has a total specialization rule. Okay, so a patient should be classified as outpatient or as a resident patient. So that's total specialization. When you say partial specialization, So partial specialization, a vehicle can be a car or a truck, but does not have to be either. Meaning, a vehicle can either be a car or a truck. Pili lang. It should be a car or a truck, but not both. One vehicle cannot be classified both as car or truck. A vehicle should be classified as a car, or as a truck. There is no such thing as a vehicle that can be called at the same time a truck and a car. So this is what we call the specialization, a partial specialization rule. For the second supertype subtype constraints in relationships, you have what we call the disjointness constraint. When you say disjointness constraint, whether an instance of a supertype may simultaneously be a member of two or more subtypes. So for completeness constraint, an instance of a supertype must be or must belong to at least one subtype. For the disjointness constraint, an instance of a supertype may simultaneously be a member of two or more subtypes. So meaning it can be present or the instance can be found in two or more subtypes. So for disjointness, you have the disjoint rule and the overlap rule. For disjoint rule, an instance of the supertype can only be one of the subtypes. The overlap rule, an instance of the supertype could be more than one of the subtypes. To illustrate, let's have this. For the disjointness constraint, particularly for the disjoint rule, we know that a patient must either be an outpatient or a resident patient. So the disjointness constraint is a disjoint rule because a patient can either be an outpatient or a resident patient, but a patient cannot be both. Meaning once you are if you are a patient, you cannot be both outpatient at the same time a resident patient. At least one classification. That is why you have the disjoint rule for that. For the second disjointness constraint, we have the overlap rule. So we know that a part can either be a manufactured part, total completeness, pero overlap siya when it comes to disjointness constraint because a part can be both manufactured or purchased from a supplier. That's the overlap rule. Now, in developing or in portraying constraints in supertype subtype relationships, it is better that you have subtype discriminator. So when you say subtype discriminator, it is an attribute of the supertype whose values determine the target subtype. For disjoint, a simple attribute with alternative values has to or values to indicate the possible subtypes. Overlapping is a composite attribute whose subparts pertain to different subtypes. Each subpart contains a Boolean value to indicate whether or not the instance belongs to the associated subtype. So example for a disjoint subtype discriminator, employee. So you want to classify the employee into three subtypes: hourly, salaried, and consultant. Now for the discriminator, you have H for hourly employee, S for salaried employee, and C for consultant. This is just how you put subtype discriminator. Then for the overlap rule, you have here for part, is it manufactured? Yes or no? So you have here manufactured, yes, then it will be stored in manufactured part. If purchased, if yes, then it should be placed or saved under purchased part. So let's now go to a supertype subtype hierarchy. So for the supertype hierarchy, so in this particular example, you can see that one supertype has 3 subtypes, and each subtypes became or one of the subtype became a supertype for another set of subtypes. So this is what we call the supertype subtype hierarchy. From the original supertype, it has subtypes, and among the subtypes, one or more of the subtypes became a supertype for another set of subtypes. Now let's go to entity clusters. EER diagrams are difficult to read when there are too many entities and relationships. So the solution, you have to group entities and relationships into entity cluster. When you say entity cluster, it is a set of one or more entity types and associated relationships grouped into a single abstract entity. So when you say entity cluster, you have to group common entities together so that it will be easier for you to read the ER diagram. So let's have here an example. So as you can see in this particular ERD, all the entities pertaining customers are grouped together. So this is considered to be one cluster. All the entities pertaining to products are grouped together, considered to be another cluster. Same with the order, vendor, then the employee, and so on and so forth. So this is how you will be modeling or creating your ER diagrams for it to become more readable and understandable by the intended users. Okay. So for packaged data models, these are predefined data models and could be universal or industry specific. It is also called a template data model. So the advantages of using packaged data models, it is that it is proven model components. It uses proven model components, save time and cost, less likelihood of data model errors, easier to evolve and modify over time, aid in requirements determination, easier to read, supertype subtype hierarchies promote reuse, many-to-many relationships enhance model flexibility, vendor-supplied data model fosters integration with vendors' application, and universal model support interorganizational systems. That's all, and thank you.